All right, welcome to video 3. We'll be going through questions 13 through 18. So this 13th question says triangle ABC is similar to triangle DEF. If AB is 6 and AC is 8, as pictured here, which statement will justify similarity by side angle side? So obviously this is from level 3, where we learned about similarity. And let's just review for 1 second the 3 ways to prove similarity. There's 1, angle, angle, 2, side, angle, side, 3, side, side, side. All right, those are the 3 ways to prove similarity. Remember, it's important that for side, angle, side, the angle is between the 2 sides. So for that to be true in this question, we know A and D would have to be congruent. All right, that would make the side, the angle between these 2 sides. So first, that helps us eliminate these 2, C and F. Because check it out, if you were to use C and F, that would be ass, and there's no ass in math. It has to be side, angle, side. So let's get those 2 out of there, okay? Those are bad choices. So now we just have to check these 2, all right? So it tells us that DE is 9 and DF is 12, or we could do DE is 8 and DF is 10. Well, the other thing we have to know is not only does an angle have to be congruent, but the ratios of the sides have to be the same. So you have to check this. 9 over 6, all right? That's your first ratio, and you want to check 12 over 8. Well, if you put 9 over 6 to check out what that ratio is as a decimal, that would be 1.5. And 12 over 8 is 1.5 as well. So your ratios are the same. You have a congruent angle. These prove it's similar. And let's just take a quick look at why the next one wouldn't be true. Okay, so the next one, if we chose number 2, that's a bad answer. That's a bad answer. Okay, and let me show you why. We know at this point that ratios of similar triangles are going to be the same. So in this case, that would say this. It says DE is 8, DF is 10. So that means 8 is to 6 is the same as 10 is to 8. Well, 8 divided by 6, if you put that in your calculator, is just 1.333333, and 10 divided by 8 is 1.25. This does not give you the same ratio. Not the same. And we need to get the same ratio. So sorry, number 2, you're out. Ratios got to be the same in similar triangles. Okay, next one. Question number 14. The diameter of a basketball is approximately 9.5 inches. That might be true. And the diameter of a tennis ball is approximately 2.5 inches. The volume of the basketball is about how many times greater than the volume of the tennis ball? All right, so what we should start off by doing is finding the volume of both of these basketballs. So this is obviously a level 10 question where we learned about 3D shapes. Now the volume of a basketball is going to be calculated using this formula. Volume is equal to 4/3 pi r to the third. All right, now both of these measurements are in diameter, so we're going to have to cut both of those in half. So the basketball will have this volume. Volume is equal to 4/3 pi times, and that would be 4.75 squared. The tennis ball, what we'd have is volume is equal to 4/3 pi times 1.25 squared. To the third. Come on, Siegel. All right? Yes, to the third. So you're going to put these in the calculator and take a look at what these 2 numbers are. Okay, so I'll take a minute to do that. You do it as well. Pause the video, put these in your calculator. Volume is 448.92 about, and our second volume of the tennis ball is about 8.18. Now to figure out how many times bigger the basketball is than tennis ball, all we got to do is divide these 2 numbers. Now, or you could just multiply each one of these answer choices by 8.18 and see which one gives you the volume of a basketball. So let's just divide these 2 numbers. All right, we're going to take 448, and we're going to divide that by 8. I'm just rounding here, 0.18. Yeah, whatever. Sorry, I'm not being super accurate on this question. I apologize. And what you get is about 54.7 or 55. Sweet. Easy. Okay, the endpoints of one side of a regular pentagon are -1, 4 and 2, 3. What is the perimeter of the pentagon? Well, this is actually a level 8 question. All right, applications of coordinate geometry, of coordinate geo. Okay, and what we should do here is actually draw a sketch. All right, a pentagon has 5 sides. All right, and what they gave us is the coordinates of one of those sides. So one of those coordinates is -1, 4, and 2, 3. All right. Now, since it says the word regular pentagon, that means each side is going to be congruent. All right, and so if I know the length of one side, well, guess what? I know all 5 sides. And to find the perimeter, remember, just perimeter means add all the sides together. So what we're going to do here to find the length of one side is to do what? You should be thinking this. That's right, we're going to use the distance formula. So distance is equal to the square root of, well, let's see this. This is x1 minus x2 squared plus y1 minus y2 squared. All right, let's plug everything in. And this distance formula will give us the length of that one side that they told us about. So x1 minus x2, that's -1 minus 2 squared plus 4 minus 3 squared. All right, so our distance is going to be equal to the square root of -3 squared plus 1 squared. Our distance is going to be equal to, that's going to be the square root of 9 plus 1, positive 9, because whenever you square a number, you get a positive number. So the distance is equal to the square root of 10. All right, so the length of our one side is 10. Now, that means each side has a square root of 10 side length. All right, and so if you look at your answer choices here, there's 5 square root 10s, that is 2. And this answer is designed for the person who, believe it or not, just found the distance on one side and thought that was the perimeter. Nice try, not happening. So, yes, it's just 5 times the square root of 10. That's what gives you the perimeter of your pentagon. Nice. Next question. Hold on. Let me just get all this out of the way. I'm sorry about this. Let me just clear this on out. Let me just clear it. Just clear it on up. Clear it on up. Clear it on up. Clear it on. And done. Woo! Look at this. This is an easy question. It says, what is the measure of angle A to the nearest degree? Well, luckily we have our good friend level 6 where we learned about trig. And if we know 2 sides of a right triangle, then we can find the angles. Right? So, what do? We label our sides and we write down SOHCAHTOA. Ka-toa. Now, we don't have an opposite side. We do have an hypotenuse and we do have an adjacent. So if adjacent and hypotenuse, that's going to be the cosine. We're looking for the angle, so that's going to be the cosine of x, and that equals 9/14. Now, since we're looking for an angle, we use the inverse trig function. That's right. So we're going to do cosine -1 on both sides, cosine -1. That cancels, and then we get x equals cosine -1, 9/14. Okay, so let's put that in. Cosine -1, 9 divided by 14. Just put that into your calculator and you get 49.9999947, which rounds up to 50 degrees. Dope. All right, 2 more questions and then we are done. Okay, check it on out. What is the coordinates of the center and length of the radius? Sorry, what is the coordinates of the center and the length of the radius in the circle with the equation x squared plus 6x plus y squared minus 4y equals 23? So first of all, this is level 9. Once again, this is talking about circles. And just so you want to know, if you're still having trouble finding the equations of circles, this is 9.6. Okay, watch that if you want to learn how to do this skill. For those of you who want a quick refresher though, it's x squared plus 6x plus blank plus y squared minus 4y plus blank, ran out of room, equals 23. And don't forget, you have to add 2 blanks to the other side, because if you're adding 2 things to this side, you got to add to the other. So how do I fill in these blanks? Well, I take 6 and I divide that by 2. I get 3. I'm going to square that number. I get 9. Then I'm going to take -4. I'm going to divide that by 2. I get -2. I'm going to square that and I get +4. So I'm going to add 9 and 4 to the other side as well. Now we just got to factor this guy down. So right here, we're going to factor x squared plus 6x plus 9 down. That's just x plus 3 squared. And then we get plus y. And this is this whole thing, y squared minus 4y plus 4. That's y minus 2. Add all this together, so that's 23 plus 9 plus 4, that's 23 plus 13, that gives us 36. All right, and that just means our center and our radius is as follows. We change the sign. We get -3 and +2. Switch those two signs, and then we get the radius is the square root of 36, which equals 6. Ooh, hold on, almost. Yes, that gives us number 4. Don't forget to switch your signs when you get your center. And then number 18. The coordinates of the vertices are RS, are blank, blank, and blank. What kind of triangle is this? Is this a right triangle, acute, obtuse, or equal angular? That's a pretty easy question. Now, if you just looked at this, I'm just saying go graph it. It's going to look something like this, all right? And you'll see that this looks a lot like a right angle. And you could check that by finding the slopes, which we all know how to do. Remember, you just got to find the slopes of the different sides to take a look. And if two sides are perpendicular, well, then you know it's a right triangle. So this, if you did this correctly, you got a right triangle here. All right, just check the slopes. You'll see that it's a right triangle. All right, guys, that's it for this lesson. Come back for 9 through 24 in the next video. Peace.